Here is a pyramid with a square base, A, B, C, D. They must have told me that for a reason. A to B is 5. Well, they told me it's a square base, so I could put B to C must be 5 as well, C to D must be 5, and A to D must also be 5. It says calculate the size of the angle T to A to C, which awkwardly isn't drawn, so I'm just going to draw that in there. And it's this angle that I'm trying to work out. Let's call it X. It does say the vertex T, the pointy bit, is 12 metres vertically above the midpoint of AC. So we'll call the midpoint M, and we'll draw in that there. Now with these questions, it's always about trying to work out, have I got some right-angled triangles? I've got a right-angled triangle involving A, M and T, which I would draw out in the exam. A to M and M to T. The right angle clearly being at M. Now very kindly they've told me in the question that T is 12 vertically above M. So I've got to now either work out A to T or A to M, and I can work out neither of those. But I do spot a nice right-angled triangle involving A and C. There's actually two options. We could choose B or D. Personally, I see it involving D. So I'll draw out that right-angled triangle, A to C to D, with the right angle at D because it's a square. And I know that A to D was 5 bits and C to D was 5 bits. I need to work out the size of A to C and then worry about what to do with it afterwards. Quite clearly a Pythagoras question. Square root of 5 squared, 5 squared, and we're working out the hypotenuse, so it's a plus. Pop it in the calculator, and the calculator says 5 root 2. I'm actually going to write 7.071. However, we don't need A to C. We need the midpoint of A to C, halfway. We'll take that 7.071 and we'll halve it because we only want the distance from A to M. A to M is 3.535, and I can write that on this diagram here. 3.535. And it's this angle here I'm trying to work out. I think I've got enough information now. I've got the side with all the shading on it, the adjacent. I've got the other side, the opposite. I'm not interested in the hypotenuse. I remember my so, car, toa, and the one that involves O and A is toa. I'll pop a T next to the X because I know I'm in the tan graph. So into the calculator, I'm trying to work out T because that's where the X is. So I'll first of all tap the tan of, and covering up T it says O divided by A, so it's 12 divided by 3.535. Then I'll realise my mistake when it says 0 degrees. It should be, to work out an angle, don't forget to get a shift on. 12 divided by 3.535, and we get an answer of 73.6 degrees, which seems reasonable. Second version of the question. Diagram shows a triangular prism. The base ABCD of a prism is a square. So again, we've got 15, 15. I could write in 15 there and 15 here as well. Of side length 15. ABE and CBE are right angles. Angle E to A to B is 35. I can see that drawn on the diagram. M is the point on D to A, such that D to M is 2 bits and M to A is 3 bits. So it's going to be slightly closer to that D than it is E. And I know the whole thing is 15. D to M is 2 circles, M to A is 3 circles. I know all 5 circles must add up to 15. 15 divided by 5 is 3. From that, I've worked out 3 add 3, that must be 6. And m to a must be 3 add 3 is 9, and I know I've done that right because they add up nicely to 15. Calculate the size of the angle between EM, so that's this line here, and the plane, or the base of the prism. So I'm looking for a right-angled triangle that involves those sides. I think the only right-angled triangle I can see involves the letter B. And it's getting a bit fiddly here. So I would redraw out that right-angled triangle, and we'll see if we can put any information on it. We've got M, we've got B with the right angle, and we've got E. Annoyingly, I know nothing about that, but it is this angle here that I'm trying to work out. We'll call it X. To work out E to B, first of all, I'm looking at EB thinking, is there another right-angled triangle that involves that? There is a nice right-angled triangle here. E to B to A. So I'll have a quick sketch of that as well. The right angle being at B. I know A to B is 15, it says that on there. It says that this is 35 degrees. Got a nice right angled triangle where I'm trying to work out the opposite. And I've got the one with all the shading on it, the adjacent. The one that uses A and O is tower. I'm trying to work out the opposite, so it's tan times the adjacent. We'll do the tan of 35 times by the adjacent of 15, giving me an answer of 10.50. It'd be nice to add that to our picture over here. We've just worked out E to B, so we'll add that onto the picture, 10.5. I still don't have enough information to work out the angle. I think it'd be nice to work out M to B. Is there a right-angled triangle involving M and B? Yes, M, B and A, the right angle being at A. I know from M to A is 9. I did that ratio work earlier on to find it. And I know A to B is 15. I'm trying to work out the third side. A little bit of Pythagoras theorem, 15 squared and 9 squared, and we're working out the hypotenuse, so I'll add them, giving me an answer of 17.49. M to B is 17.49. I now have enough information. I've got my one with all the shading on it, the adjacent. I've got my other side, the opposite. It's still tower. I'm trying to work out the angle. T on the calculator is of course tan, and it's O over A. So it's the tan of 10.5, the opposite side, over 17.49. Again, don't forget it's tan to the power of minus 1 because we're working out the angle. 10.5 divided 17.49, giving me an answer of 30.97. I think to one decimal place, rather strangely, the 9 will round 30 up to 31, and you would need 31.0.